My name's Clayton Wilkinson. I work in developer relations with games and Daydream. And one of the things I remember growing up as a child is going to the Air and Space Museum, and they just opened up a new movie theater, and they were playing this movie called To Fly. And it was a small theater, really steep, but when the balloon took off and they went over this cliff, then the whole screen opened up into IMAX, and I was just blown away. And what really excites me now is I can take these types of experiences and make them a Daydream and bring them to other people. So I want to go over a few things here that will help you make your own Daydream applications for video. So we're going to walk through three things. The first one will be some design considerations with Daydream. It's a little different than a normal mobile app. The second one will go over video quality and what makes video good and what makes it bad. And finally, Unity, which is a really great tool for making Daydream apps. And then also some components we've made to really jumpstart your application development. So VR is a little bit different. You've probably heard some of these things before. It's designed to bring a new reality to people, to give them a new experience. The sessions are a little bit longer. You've got 40 minutes, maybe longer, of sitting in a relaxed spot. You're not walking around. You're not sitting in a conference. You're really focused on the application. So you have to take that into account. And if you think about the range of motion, you have about 70 degrees to work with. It's about 30 degrees from either side comfortably. If you really want the user, they can stretch, maybe rotate their shoulders, and they can see 80 degrees either side pretty comfortably, but it's still a stretch. So we want to keep the main focus of the application really there in the front, in that 70 degrees. And in terms of distance, you really want to be somewhere between 0.5 meter and 20 meters away. That's kind of the virtual distance you want to work with. Anything that's up close, you really end up straining your eyes, maybe crossing your eyes to try to focus on that. And far away, it really turns into something flat, and there's not a lot of depth perception. And speaking of depth perception, you really want to have some texture and shadow in your environment. So you can see here, before the texture was added to these squares, they just kind of look like blobs. But now that we've added a little texture and a little shadow, you can see that there's really 3 boxes and the circles moving around them. So all these mechanics are good, but you really need to think about the environment that you're in. So you want to convey some presence. You want to take them somewhere. And if you look at this screen, it would be a great screen for maybe a web page or something. It's a little plain, but it really doesn't convey anything. And something I see a lot of, and I do a lot of in my prototypes, we're all guilty of it, is kind of these void spaces. So you make the space and then an infinite plane, and you put your content in it and throw it there, and it's fast. It renders very quickly. It gives you that sense of VR-ness, but it really doesn't take you anywhere. It's not very memorable. So you really miss this opportunity to make something memorable in your application. So if you look at the Daydream home screen, it does a really good job of this. It's got some environment that you can look at, things to focus on. You kind of follow that water into the center of the screen, and then you have your content. So this is really to focus your attention on the content. And you can do something even crazy, like this example here, where we've taken the same content, but we've kind of integrated it into the environment. So you've got the rock there that is framing the menu at the bottom. And you've got this sunlight coming through the trees that's kind of a spotlight on your content to really focus the eyes there. The challenge here, though, is this really is hard to do if you're going to move the content at all. So you don't want to move the menu back, for example, into the rock. Or you've got to move the rock, and it gets very complex. So this is kind of the very extreme case. If you can do this, fantastic. But you normally end up with some compromises. So you can make a great environment and great presence of your app, but you really need to have great video to have a great video app. And the first thing when we talk about quality of video is resolution. So this is the number of pixels or the number of samples in the frame that we're looking at. And as you can see, there's a wide range from the very low definition, so maybe these are things that show up on television or on little game devices, all the way up to 4K, which is kind of the cutting edge of what you can find both on mobile devices and televisions today. And these are the kind of the proportional relationship that's not to scale, but they're relative to each other, they're scaled. And there's a lot more bits to move as you get into the higher resolutions. And you've got to think about that because it's going to take more CPU, it's going to take more time, more bandwidth if you're streaming, and you have to be aware of that. So you want to balance your resolution to the quality of the content that you're sending. Now, when we talk about resolution, you usually hear numbers like 1080p or 720i, and this is what those P's and I's mean. So you've got progressive. Progressive means that every single line is shown, and you get a complete picture, where interlaced is every other line. And this allows a trick that in a movie where half the lines are sent the first frame, and the subsequent frame, the second half is sent. So you can have a very large resolution and only use half the bits every frame. And so this gives you an advantage of bit rate. The price of it is the quality of the video. It can be a little bit softer, maybe motion is blurry. So you want to be aware if you're going to use an interlaced video that you've got slow motion and kind of a soft picture. Also with the capturing of the video, you've got aspect ratio. And aspect ratio is that, the ratio of the width to the height of the screen. And you want to make sure that when you present the video back to the user, you're aware of the aspect ratio it's captured with. If not, you'll see what happens. Like here, we've got a 4:3, which is kind of a standard definition ratio, shown on an HD screen. And so it stretches it out, and it looks kind of weird. Also in VR, we have the opportunity to do 360 degrees. So this is fantastic. You can take a picture, and I've seen some of people holding them up in the cameras, walking around outside also, and you get these spherical views of the world. So here's one I took on top of our San Francisco office one day. And you can kind of see the middle part of it looks pretty normal, but as you get to the top and bottom of the image, it gets really stretched out. And so you have to be aware of what projection was used by the camera so that you can show the same projection when you render it. So the most common one is called the equirectangular projection. And this is where it kind of unfolds the sphere into a rectangle and stretching the top of the sphere along the top of the rectangle and the bottom. So the poles get very distorted, and the middle part is very clear. And so you can see once I put it back on the inside of the sphere, the distortion goes away, and you can see the Bay Bridge very clearly. You can also do stereo vision. So we've all been to 3D movies where they do polarized views. Well, you can also do stereo projections in VR where you've got two separate images for each eye. Maybe the left eye is on top of the right eye, like in this example. And here, each of them are slightly different, slightly offset, so when you show them side by side, your eyes see the difference in depth perception, and it looks stereoscopic. So all of this was about the dimensions and the resolution aspect ratios of a single frame. But when you look at a movie, it's made up of lots of frames. And that's called the frame rate, of course. And so here are all the frame rates that you'll probably ever encounter. And as you can see, it's a long list. And there's no right frame rate or wrong frame rate. It mostly has to do with the capturing. So at the bottom is typically, like a standard movie would be 24 frames per second, something like that. And television tends to be around 29.97 or 30 if you're in Europe. And then specialized HD cameras, digital cameras, tend to get up into the higher frame rates. And this is important to understand when you're playing back, because if you're playing it back too slowly, if you've captured a very fast frame rate and you're playing it slowly, it might look a little jerky because you're skipping frames. And alternatively, if you've got a low capture, you're never going to be able to speed it up faster than that capture rate and have any appreciable improvement in quality. So now that we've got multiple frames coming at us, different resolutions, we want to be able to do things with that. We need to read it, process it, decode it, put it on the screen. Maybe we're downloading it from a server. And so we talk about bit rate. And this is where they call them encoders or codecs come into play. So a very common one is the H.264 encoder. And that's found on almost every device now. And they're usually implemented in hardware. The H.265 encoder is coming, and it will be on more modern devices, and it's much more efficient at this compression. So you can see these are the recommended data rates for H.264 for the different resolutions. And so you can imagine trying to push 40 megabits a second over a crowded Wi-Fi connection might be a little challenging. So you may have to scale it down if that's your environment, or you may need to be aware of that and not do a lot of processing around the video if you have special effects and things like that. So let's talk about Daydream. If you look at the Android standard specification, this is what we say to vendors, that if you want to be Daydream ready, these are the things you need to support in your device. And so 264, H.264, of course, is there at 4K, so the maximum resolution we really can get is 4K at 30 frames per second with 40 megabits per second transfer. So this allows them to measure how much CPU is needed to actually get the video decoded and on the screen. And then we also ask for 265. So it's so much more efficient that you should be able to get the 1080p at the same frame rate, but a quarter of the data rate, because 265 is that much more efficient. So equivalently, we're saying here you can run 4 1080p video streams at the same time on the same device if you're using H.265 encoding. And you can see the minimum resolution that we want is that 1080p. But ideally, you've got a higher resolution so you can get a much nicer and richer view. So when we talk about VR, it's a little different than just watching a movie or a YouTube stream on your device in your hand. Since you're holding it up and in the viewer, and you're looking at it with essentially magnifying glasses, you want to be able to have a really high quality image so you're not really distracted by little imperfections in the video and things like that. So the minimum we recommend for a monoscopic video, so where both eyes are seeing the exact same image, is there, the 1080p, 30 frames per second again, and about 16 megabits per second. So that's pretty comfortable, it's pretty easy to get that, but it gives you a very nice image. And then if you're doing 360 or stereoscopic, there's really double the amount of information you need. So 360 degree with that equirectangular projection, the majority of the bits are not seen by the user at any one time. They're behind you or off to the sides. So we want to double the resolution and really get up there to the 4K size, so that way half of it is shown in the eyes and it looks very good. And you can see the difference really of bit rate. So it only went to 24, not to 32, if there's any math whizzes out there. And that's because of this compression. So the encoder, as it's compressing, will find repeating sections of the frames as you get larger, so it can compress more effectively. So now we've got a bit rate, we've got a file like a MPEG-4 file or something, and we need to do something with it. We need to get it onto the device so we can actually show it. And there's a couple different ways to do that. The first way, of course, is to download it. You could package it up into an auxiliary file, an OBB file, and download it off the Play Store. Or you can put it on your own server and download it there. So maybe you've got sports highlights every week or current events in the news, and it just gets downloaded, and then they can play it offline. So this is great because if you don't have connectivity all the time, your user doesn't, they can download it and then play it back whenever they want to. They don't need to be connected to the internet. You're also easy to encode these because you don't have to worry about multiple resolutions and multiple data rates, like if you were streaming. And you can have really easy delivery, like I said. The downside is you've got to figure out what to send. So you need to do some catalog management and curate your list a little bit more closely. You also need to have a way to delete files that you're not using anymore. So after a year, you don't want to fill up the user's device. On the streaming side, we're all pretty familiar with this. YouTube streams. There's a couple other companies out there that stream. And the great thing about it is there's tons of content. You can have an internet full of content and just be able to select it and then play it back. The user's not expected to download anything they're not using, so they like it. It's really eat the bandwidth as you use it type of model, which is great. And everyone seems to understand how to use it. So they know how to get on, log on, and start streaming video pretty easily. The downside is this encoding problem. So as you saw, especially with larger, high-quality videos, the speed creates a bitrate problem. And to be guaranteed a high bandwidth connection on Wi-Fi sometimes can be challenging. So what you want to do is encode at multiple bit rates. So usually you do that by different resolutions. So you start with a 4K stream for your best quality, and you go down to a 2K and maybe 1080p. And from there, you use a server that's using something like the Dash or the HLS protocol to switch between these different streams seamlessly. So the user may see a little degrading of the quality. It gets a little fuzzy for maybe a second, and then we'll jump back up as network conditions improve. So now we've got all this video, and we figured out how we're going to get it there and all that. We'll go ahead and look a little bit at Unity. And not everyone's seen Unity. So the first thing I wanted to do was just give a quick tour of the Unity editor. So as we talk about things, you'll kind of understand. You lay out a 3D scene here with the hierarchy on the left. And like, for example, here's a camera, and you can see what the camera sees. And you can set some properties in this property inspector over here on the right. And in order to make it Daydream capable, you have to turn on the VR support. So you do that here on the Android side by just checking this little box and then selecting Daydream out of this. One of the important things to remember is when you're watching videos, it's going to be a long time. It's not just going to be 30 or 40 minutes. It might be an hour or 2 hours. So you really want to make sure that that sustained performance mode is checked. So now you've got a scene. You can add simple models to it. So here, built into Unity, you can add cubes and planes and triangles and cylinders. And here's one, you can move them around. More complex things you would build in a modeling tool, and you can import them. And we can also change behaviors of the cubes. So here we can add like physical things to it. We can call a component a rigid body, for example, which adds mass, and it interplays with the physics system. We can turn off the gravity in VR mode, of course. And then we can add custom scripts, and this is where the application building comes in, that will add custom behaviors that you script in C#. So here we can make one called spin that will spin the cube. And you just, here when the application starts, you would just grab that rigid body and then call add torque to this, and it will start spinning the object here. That's pretty exciting. So here, to make it more exciting, we would take one of these 3D models that we've built, so an environment, for example. And here is, whoops, one too many clicks. So we can add these prefabricated components. So these were made outside or in a different instance of Unity. This particular one was a room we made and just kind of modeled some shapes on it to give it a little bit different feel. And so it gives it a completely different feel. It's the exact same program we just ran. And so you can see the real power of getting that environment set. So here's kind of a block diagram of everything that's involved in that Unity app. So we've got Unity itself there, which contains the scene, the 3D models, the C# script that you would write. We add to it also the Google VR SDK, the GVR SDK, which you can download from developers.google.com or from GitHub. And then part of this is a video plugin that connects the Exoplayer plugin, which there was a talk yesterday about it. You can see it on YouTube if you didn't see it and you're interested. There's also some code labs about it. But this really wraps the media services in Android into something that's very digestible and customizable and simple to work with. And then it also handles communicating with the VR services that are part of the Android operating system. And these systems that are part of Android handle these things for you, so you don't have to handle them in your application code or as you're drawing in Unity. Async reprojection is this concept of being able to turn your head very fast, and instead of trying to draw a continuous stream as you're turning your head, async reprojection can detect your head motion and then draw the existing image in the right place. So as you turn your head to the right, it kind of moves to the left, and you don't get that nauseous feeling like nothing's moving. It also handles lens distortion. So again, those lenses in Daydream are essentially spherical magnifying glasses. And we want to present to that a distorted image, so when it goes through the lens, it will be corrected. And this handles adding that distortion automatically, so you don't have to do it every time. There's also support for spatial audio. So this allows you to put sounds in your 3D model, and sounds will emanate from behind you, and as you turn around, you'll be looking at the sound, and your ears and your eyes will continue to be in sync and build that illusion of being in a different place. And of course, there's the mechanics of head tracking and the controller. Exoplayer, this is a super simple model. And if you need to know more about it, I would definitely point you back to YouTube for yesterday's talk and the code lab you can do in the code lab area for today and tomorrow. And what this does is it gives you a capability to customize each step in this process of playing the video. So if you think about a video itself, like maybe an MPEG-4 or a stream on a server, there's a data source. And that data source can be in a variety of different formats. And then that needs to be extracted into the decoder. And so the decoder is going to take those bits that you got off the file or off the internet, and it's going to decompress them into a video stream, audio streams, maybe closed captioning, and then feed that to the Exoplayer class itself. Now, in the class itself, it's going to handle buffering, because it's not going to be able to decode as fast as it's playing back. So we usually do a little bit ahead of time. And that way, there's plenty of data to consume as we're rendering. And then under application control, there's the track selector. The track selector says, you want to show this video and this audio. Maybe you have multiple audio streams for different languages, or maybe you have a stereo and mono, and you want to have different selections for those, or different resolutions. And you can select the tracks and show those through the renderers. And the renderers are the thing that actually draw or render sound. So there's a lot of moving parts to this, and it can be kind of overwhelming, as we found as we started building some of these samples for Daydream. So we decided to bundle them together into a media app template. And this template will be available on GitHub shortly. I don't think it's there today, but it should be very soon. And this gives you the Unity building blocks, these prefabbed models and scripts that will allow you to really jumpstart your application, and you can focus on delivering a great experience to the user rather than how to decode video. So the first thing we've added to it is this selection system, and with breadcrumb navigation. So you've got a series of folders, and you can make your own categories and put videos in them, and then you can navigate up and down the hierarchy. Another thing we did was add this capability of not only showing the video, but sampling it and creating a light source in Unity that's representative of the video frame that's being shown at that time. So you get this nice emissive effect from the video, like a glow from the screen or the television or whatever it is. And it adds really a sense of warmth and being to the screen. It feels like it's really there. We also found that not everyone likes to sit in the front row at a movie theater or in the back row. So we allow zooming of it. And you can see this also in the YouTube Daydream app, where it allows you to actually move the screen in and out to where it's at a comfortable position for you to view. And it makes a really big difference when you're trying to sit there and watch a movie for an hour. You want to be comfortable and relaxed. And being comfortable and relaxed doesn't always mean being level. So Daydream always wants the horizon to be level and straight ahead. And this allows you to tilt the screen. So if you're leaning back in your chair or you're lying on your bed, you can move the screen up and you don't have to crane your neck to look down at the screen. So again, this is another comfort thing. And also 360 repositioning. So I don't know how many of you have tried to look at a 360 video or even image in Daydream, but it seems like, at least for me always, I pick it up and the main thing I'm supposed to be looking at is over there. And so I end up looking around, and I was like, oh, there it is, now I can look at it. So this allows you to pick it up and move it back into your center so you can be comfortably seated again and the subject is right in front of you. And of course, playback controls. So you could spend a lot of time making playback controls. We decided just to make some for you and save you the headache. Now, we do a pretty good job of looking at the stream when we're playing it back and trying to determine what format it's in. So make sure we get the projection right, aspect ratio can be adjusted. If it's stereoscopic, is it side-by-side eyes? Is it top and bottom eyes? But sometimes we don't choose right, or maybe you just want to explore and try different things. So you can do that here by changing the projection manually as well. So just kind of summarize what's in this media app template is really all these prefabs here that you can pull into your own project, customize, and integrate into your application. We've got the breadcrumb and the title, You can tilt and zoom the screen, which is great, and the playback controls, and of course that emissive lighting, which is really tricky to get sometimes. So kind of wrap everything up. I know we've covered everything, and just want to have one checklist to cover these things. And you really want to keep the user comfort first in hand. Having them sit in a comfortable place and not have to move their shoulders around or look up and down is going to make your app that much enjoyable, and they'll go back and play it again and again. You want to take the opportunity to make a destination, a place that they can go. So when they think about it, they'll go, oh yeah, I want to watch this video in the sports arena or whatever environment you decide to make. And it gives them something else to remember rather than that empty space. You want to spend some time looking at your encoding as well to make sure that you're delivering the best quality video you can possibly get in the constraints of the application you're really targeting. If you're targeting offline people, you want to target downloading those things and having good encoding. If you're targeting streaming people, then you have to encode in these other bit rates to make sure that everything can be switched depending on network quality. And you really want to match as best you can what information was used when they capture the video. So the aspect ratio, you don't want to try to recalculate aspect ratio on the fly. Or if it's in the rectangular projection, you want to make sure that your sphere is pretty close to the sphere they used. And that way, your images look great, just as great as they were when they were captured. And finally, delight your users. I mean, that's why we're here. We love to make great apps. And so make whatever you do really enjoyable. And think about how they're going to use it. And would you use it over and over again? Because if it's a one-time deal, great, that's fine. But you really want something that they'll use over and over and over again. So here are some links to get things. Definitely the Daydream overview site is a good starting point where there's many more links to different samples and these GitHub repos. And again, Exoplayer is very configurable, very, very powerful. I would suggest checking out their site as well as Code Labs and maybe their talk. So thanks for your attention today.